Second, B group consists of As3 plus, Sb3 plus, Sn2 plus, soluble in yellow ammonium sulfide, that is NH4 whole twice Sx, as NH4 whole 3 AsS4, NH4 whole 3 SbS4, or NH4 whole 2 SnS3. Remember, Sn2 plus is oxidized to Sn plus 4. Collect this solution and add dilute HCl and filter. The residue or the insoluble remains As2S3 with some sulfur, while the filtrate, the soluble part, contains SpCl3 and SnCl4. Let us first discuss the filtrate, the soluble part. Divide this solution into two parts. To the first part add ammonium hydroxide plus oxalic acid, crystals, saturate solution, and then pass H2S. We get orange precipitate of antimony sulfide. Dissolve that precipitate in concentrated HCl. Add excess of water. We get a white precipitate of antimonyl chloride SbOCl. Then add tartaric acid to this white precipitate, or dissolve this white precipitate into tartaric acid. The precipitate becomes soluble. To the second part, we add some iron powder or zinc dust and then add mercury chloride. A black-gray precipitate is obtained that confirms the presence of tin. Let us go back to the residue that was of As2S3 plus some sulfur in the form of impurity. To this now add concentrated HNO3 and divide into two parts. To the first part add ammonium molybdenate solution. We get a yellow precipitate. To the second part add ammonium chloride, then ammonium hydroxide, and then magnesium sulfate. A white precipitate is obtained. Both these reactions confirm the presence of arsenic in the salt or the mixture. The chemical reactions represented by corresponding chemical equations are given below. For As3+, the reactions are 2NH4 whole 3 AsS4 plus 6HCl. We get As2S3 plus 2S. This sulfur is precipitated in the form of a light yellow PPT, plus 6NH4Cl plus 3H2S. The second equation is 3As2S3 plus 28HNO3 plus 4H2. We get 6H3AsO4 plus 9H2SO4 plus 28NO. Thus nitric oxide is evolved. The third equation is H3AsO4 plus 12NH4 whole twice MOO4. This is ammonium molybdenate plus 24HNO3. As a result of this we get NH4 whole 3 AsO4 dot 12MOO4. This gives a canary yellow precipitate plus 24NH4NO3 plus 12H2. The fourth equation is H3AsO4 plus MgSO4 plus 3NH4OH. We get MgNH4AsO4. That forms the white precipitate as shown in the chart above, plus NH4 whole 2SO4 plus 3H2. Let us now learn the reactions shown by Sb3 plus ion. The first equation is 2NH4 whole 3 SbS4 plus 6HCl. We get Sb2S5 plus 6NH4Cl plus 3H2S. Second equation is Sb2S5 plus 6HCl. We get 2SbCl3 plus 3H2S plus 2 sulfur. The third one is SbCl3 plus H2O. We get SbOCl. This is the white turbidity formed in the solution, may be a white precipitate, that is antimonyl chloride plus 2HCl. This antimonyl chloride's white precipitate or turbidity gets dissolved into solution of tartaric acid as shown in equation number 4. So there we get antimonyl tartrate, a soluble compound plus HCl. Finally, for Sn plus 4, the first equation deals with the reaction between SnCl4 and zinc to give SnCl2 plus ZnCl2. Then second one is SnCl2 plus 2HgCl2. We get Hg2Cl2 plus SnCl4. Then SnCl2 plus Hg2Cl2 will give SnCl4 plus 2Hg. The same reaction we have already learned in second A group for testing mercury. So here we get black gray type of particles of mercury.